Hi guys, let's look at lesson 2 of our topic, linear equations in the form of y equals m times x. Alright, we have a graph that's showing the distance that a car travels in miles, dependent on how many hours the car has been traveling. So the graph shows the distance d of a car, the graph shows the distance d a car travels in the time t at a constant speed r. We can tell that we have a constant speed because we do have a linear graph. We have a linear equation and our graph makes a straight line. So we know we're dealing with things that are constant. What is the constant speed of the car? Okay, let's kind of look into this. Well, at 1 hour, the car goes 30 miles. At 2 hours, the car goes 60 miles. At 3 hours, the car goes 90 miles. It looks like they're traveling at a rate of 30 miles per hour. "30" is the unit rate. 30 miles for 1 hour. How far will the car travel in 2 hours? Let's go look. In 2 hours, the car will travel 60 miles. How long will it take the car to travel 120 miles? Let's find 120 miles and use the graph. It will take 4 hours. Write an equation in the form d equals r times t form to model the situation shown. We know that the distance always equals the rate times the time. I think that's probably even something you've talked about in science class. So the distance, well, the distance is always changing. That's a variable. The rate, we know that. It's constant. It's always 30. And the time is also always changing. Again, that's a variable. So the distance is varying. The rate is always 30 times the time, which is also a variable. It's always changing. So the equation d equals 30t represents this graph. All right, here's another one. The graph shows the distance d a train travels in time t at a constant speed r. Write an equation in the form distance equals rate times time that models the situation shown. Okay, so the distance is always varying. The time is always varying. But we have a linear equation which shows we have a constant rate. So we need to look at what the rate is. Well, let's see. At 1 hour, the train travels 100 miles. At 2 hours, the train travels 200 miles. At 3 hours, the train travels 300 miles. So the train is traveling at a rate of 100 miles per hour. The distance varies. The rate is constant. It is always 100. And then the time also varies. This equation, d equals 100t, represents our situation. You can use it now. Say you want to know 3 hours. 3 is the time. When we plug that into our equation, we find that d equals 300 distance, so we're talking about miles. And if we check on the graph, yeah, it does. Okay, this equation models the graph and can be used to answer questions about this same situation. Recall that the graph of a proportional relationship is a line that passes through the origin. We talked about that in our last lesson. We need a straight line and we need it to go through the origin. An equation that models a proportional relationship can always be written in the form y equals mx, or y equals m times x. This equation shows that y is always a constant multiple of x. M is standing for a constant multiple. M is also considered, sometimes we call it our constant of proportionality. Or even we've called it before our unit rate. An equation in the form y equals m times x is an example of a linear equation. An equation is a linear equation if the graph of all of its solutions is a line. Okay, so anytime we have a proportional relationship, since we know it's going to make a straight line, we're talking about a linear equation. And it's always going to have an equation of this form, because this form of an equation is showing a constant multiple. We should probably make a note that m is the constant multiple. It's the constant of proportionality. And as we've learned before, it's always equal to our unit rate. Maybe one other thing you might remember is that we always find it by doing y over x. Y is always our dependent variable, and x is always our independent variable.
I think we have a problem. The freezer broke last night.
A restaurant is running a lunch special. Write an equation that models the lunch price, y, based on the original price, x. All right, it says that the lunch special is that all prices are 1/3 off. If it's 1/3 off, how much are we going to have to pay? If 1/3 gets taken off, how much is left? Well, we have to pay 2/3. So we pay 2/3 of the original price. The lunch price, y, is 2/3 of is a key word. That's right, times the original price, which we have used as x. This equation is in the form y equals mx, or m times x. We have y equals some number times x. 2/3 is our constant multiple, or our constant of proportionality. A hamburger made with a certain type of beef loses 1/4 of its weight while cooking. Write an equation that models the weight of a cooked hamburger y based on the weight of the uncooked hamburger x. Why don't you pause the video and see if you can do this one on your own. This one is a lot like the one we just did. Okay, so if it loses 1/4 of its weight, how much of its weight does it still have? If it loses 1/4, it still has 3/4. So the weight is now 3/4 of the original weight. The weight it is now is y. Is 3/4 of indicates we're multiplying the original weight before it was cooked. That's x. So our equation is y equals 3/4 x. 3/4 is our constant multiple, or our constant of proportionality. The number of words y you can type in x minutes can be represented by the equation y equals 55x. The number of words your friend can type in x minutes is modeled by the graph. So your words are the equation. Your friend's words are not modeled in an equation, but in a graph. We need to figure out which person can type faster. Well, we can look at our equation. What is the value of m? M equals 55. This equation is in the form y equals m times x, where m is 55. 55 is our constant of proportionality. Well, that means it's also our unit rate. So that means that you can type 55 words per minute, or in 1 minute. It's a unit rate. Let's look at the graph. Let's see if we can figure out your friend's unit rate. Well, let's see. In 3 minutes, your friend can type 150 words. In 6 minutes, 300. 9 minutes, 450. It looks like we have 150 words every 3 minutes. Well, what would the unit rate be? How much in 1 minute? Your friend can only type 50 words in 1 minute, which is a little less than you. Your typing is a little bit faster. An equation that could represent this graph, your friend's typing, would be y equals mx, where m is the constant of proportionality. We know that the unit rate is always our constant of proportionality. 50 is our constant multiple. Let's even just double check our equation to make sure it works. Let's try 12. We know that should make 600 words. Well, if we use 12 for our x value, does our equation also calculate 600 words? Yeah, it kind of checks out. We know that this equation models the graph. And we would say that you are the faster typer. Okay, go ahead and pause the video and try this one out on your own. It's just like the last question we did together. All right, so a car travels y miles in x hours with the equation y equals 65x. So the unit rate for the car is 65 miles in 1 hour. Remember that y is always over x, so we're talking about the miles over the hours. All right, let's investigate the train. The train's speed is graphed in this coordinate plane. So we want to look for maybe a unit rate. This could help us understand how fast the train is going. Well, it looks like in 1 hour, the train goes 75 miles. So we can obviously tell that the train is traveling at a greater speed. If we wanted to write an equation for the train, we could write y equals 75x, as 75 is our constant multiple. We always multiply the number of hours times 75, and we get the number of miles, because the train is traveling 75 miles every hour. All right, that's it. See you for the next lesson.